It's been a difficult year. The pandemic rages on and travel restrictions are still in place. Then there's been extreme weather events and the alarm bells ringing of the climate crisis. During the pandemic, a chip shortage emerged, and headlines such as chip wars, US, China, and the battle for semiconductor supremacy, and chip wars of the 21st century hit the news. Although a full-blown crisis was averted, the shortage sent a warning signal around the globe about chip production and our dependency on such technologies. What if production stopped or materials for manufacturing chips became scarce or deplete? The chip crisis came knocking on my door recently when I tried to order a chip for an instrument to discover there was a 2-year back order. Let's backtrack a little. I work in the area of DIY electronic music, self-built sound devices. I like making electronic music in large groups, sometimes exploring technology or different media. It's mostly a live practice, performance. You could call it participatory events, making stuff to make sound and then making performance from this stuff. Performance installation, a music of things. I've used these terms. Technology is often reduced to its bare bones. Can I make a synth or sound circuit with one chip? Or some wire, a bit of wood or some nails? How can I then play it? What music can I make? I firmly believe in a radical approach to electronic sound and music. By this I mean a music that is made from the root, from the bottom up, making from scratch. The sound circuits I make can be thought of as a form of composition. I don't know if this then gets in the way of other people using these circuits. You know, it's got too much of my personality in there. But for example, the series of synths I designed for Mute Records have been used by lots of people. They're budget synths, relatively speaking, affordable. I've always been interested in the broad area of access in the arts and music. I've always thought, for example, that instead of buying an expensive vinyl record set of your favourite electronic music artist, you could buy a small handheld synth and make your own electronic music. I'm very much drawn to what might be thought of as a reductionist aesthetic. For example, minimal resources for electronic sound or low-level electronics. But the question of why is more complex. There are a range of influences. Schumacher's small is beautiful. The slow movement against faster is always better. Neo-Luddism, a form of criticism of technology. Second-hand Zen Buddhism, and John Cage. And Levi-Strauss's bricoleur, expediency and making do with what you've got. Or this interest in reductionism might simply stem from academic rigour, getting to the root of the problem, or trying to discover the essence of something. Most of the time I'm fighting not to be overwhelmed or alienated from everything around me. Reductionism is an attempt to encapsulate things into simpler forms, to make sense of these things. It's kind of existential. Yes, there is always something cathartic in adopting a reductionist aesthetic, particularly in an age of information overload and future shock as described by Alvin Toffler. Low-tech, low technology, and lo-fi, low fidelity are also related to the idea of low-level electronics. Low-tech is also deeply rooted in hacktivism and the concept of DIY sound making. In fact, it's hard to separate the idea of low-tech from DIY practices. Low-tech implies working with a technology that is immediately at hand and available to the individual, the yourself part of DIY. Part of Lowtech's magazine's manifesto serves as a broad definition of the term low-tech. Lowtech magazine questions the blind belief in technological progress and talks about the potential of past and often forgotten knowledge and technologies when it comes to designing a sustainable society. There are multiple perspectives from which low-tech can be viewed. Low-tech can be considered an approach that is politically motivated and critical of means of production, particularly large-scale mass production. It's anti-high-tech in that high-tech is seen as the harbinger of great productivity and efficiency and capital in the Marxist sense. Older, obsolete and pre-industrial technologies are often thought of as low-tech, technologies that are associated with craft and folk arts and tools and technologies of the hand. But old and new technology can be relative. This is exemplified by sound artist Hancock, who, when describing a performance of his piece Computer Music 1, Exploded View, where an old computer is destroyed in performance by dripping salt water onto the computer's motherboard, related how audience members in certain countries would be horrified by this high-tech profligacy and ask for remaining parts of the computer. Low-tech also points to low-cost, affordable technologies. We can also think low to the ground, earthy, of the root and radical. Something too at a primary stage, raw, unprocessed, natural. A final note, and of significance, is what actually constitutes low and high tech is not absolute and is best summarised by Ursula Le Guin. One way to illustrate that most technologies are in fact pretty high is to ask yourself of any man-made object, do I know how to make one? Anybody who has ever lighted a fire without matches has probably gained some proper respect for low or primitive or simple technologies. Anyone who ever lighted a fire with matches should have the wits to respect that notable high-tech invention. Lo-fi, low fidelity, is a more complex consideration in relation to DIY sound, DIY sound making, in that the term is often used misleadingly. Fidelity, faithfulness, would seem pertinent to the reproduction of sound and recorded media. Yet, the DIY electronic musician is arguably preoccupied with creating authentic, first-hand relationships with sound-making materials. Additionally, lo-fi is associated with a certain type of sound material. Such materials include crackles, hisses, pops, and noise, wanted and unwanted, sound artifacts of specific media, or the degradation of that media, or failing technology media. I have argued, with many DIY and self-made instruments, the issue of sound reproduction is redundant. A square wave generator produces a square wave. It is 100% faithful in the representation of itself. It is high fidelity. What is perceived, therefore, as lo-fi sound is bound to both technological and phenomenological issues. A notable difference between the DIY electronic musician and the music technologist is that the DIY electronic musician looks to naive approaches, expediency and ad hoc methods in their makes. Low-cost solutions are often sought. In essence, the DIY electronic musician is concerned with access. Materials at hand are gathered or older technologies appropriated, or electronic components and parts are bought cheaply online. Knowledge of making stuff is gleaned from online how-tos and videos. The entry point for making electronic sound can be as little as a few pounds. The DIY electronic musician can also operate outside of the traditional recording studio or the well-trodden paths of electronic music making. I've also suggested a decentralized approach to making electronic music, working outside the confines of the recording studio and working at a community level. Access is a major motivation for the DIY sound making artist, although doing it yourself is not necessarily cheaper, and the DIY electronic musician's motivation is often driven by artistic aesthetics rather than affordability. In the film The Sparrow and the Crane with Afro-Rack for this festival, I talk about some of the single chip instruments that I've made using nails, wood and wire wrapping techniques. One example of these instruments is the Radical Nails that is built using a single microprocessor and direct digital synthesis, DDS. The minimal parts focus the mind on the very few material things that make up the instrument. Thus, these materials demand attention. Tim Ingold put forward the idea of thinking through making, and Garnet Hertz coined the term critical making as a way of reflecting on and critiquing society. Critical making is also a handmade book publication, a collection of essays, statements and rough sketches that explore how hands-on productive work making can supplement and extend critical reflection on technology and society. The publication also covers a range of activist issues, for example, environmental, e-waste and recycling, open source approaches, DIY citizenship, and DIY and techno-scientific production. Subsequently, Hertz has taken up an overtly political agenda in Disobedient Electronics protest. The publication presents a manifesto of sorts that states, amongst other things, building electronic objects can be an effective form of social argument or political protest, and the fad of maker culture is over. Arduinos and 3D printers are fascinating things, but the large issues of what it means to be a human or society needs to be directly confronted. It can be argued that critical making builds on critique of technology found in social political writings of the 19th century, particularly Marx, regarding the reclamation of the means of production, physical or emotional. Designer Will Gaver writes, "If technology is to become ambient in the sense of surrounding us throughout our lives, the question is not only what form it should take, web pages, ubiquitous computing, tangible media, information appliances, etc., but what roles it might play in our lives. What is technology good for? How can it support our values, individually, socially and culturally?" Anthony Dunn's The Electronic Post-Optimal Object presents a similar viewpoint. Dunn argues that optimization, speed, efficiency and durability should not be the sole aim in the design of electronic products, but rather we should look beyond the quality of our relationship with objects themselves to the aesthetics of the social, psychological and cultural experiences they mediate. Both Gaver and Dunn's ideas fit within what can be broadly considered as speculative design, where there is a re-evaluation of technology and its usefulness and technological progress in relation to societal issues. Returning to sound, the emergence of the distinct field of music technology and the digital audio workstation has resulted in the predominance of certain tools and software for sound creation, often dictated by a small group of global companies. Users of such tools are locked into software licenses, subscriptions and upgrades. The ubiquity of tools has arguably led to the rise of the DIY electronic musician, sound maker, and their political motivation. Paul Thieberge, in Any Sound You Can Imagine, discusses the idea of prefabricated sound that emerged in the 1980s for synthesizers and samplers. These sounds came as presets stored in synthesizers ROM and RAM, and according to Thieberge, enabled the commercial development of the synthesizer by simplifying the operational characteristics of the technology and eliminating the need for the musician to become proficient programmers. Whereas it can be argued that the introduction of prefabricated sound helped the democratization of technology and music making, this introduction also led to a utilitarian approach to electronic sound. It's from this perspective that we can begin to evaluate the motivation of the DIY electronic musician. From this discussion, we can see how things that make sound and making sound are closely intertwined. The issues of prefabricated sound and bespoke sound touch on a number of big themes relating to self-identity, self-sufficiency and self-determination, as well as originality and authenticity. Bespoke also suggests tailor-made, a one-off, and by default an original. A bespoke sound-making device is, in the context of the DIY electronic musician, made by and made for the same person, a form of hyper-individuality. The making too could be a means to create the original. But how original are some of these devices or circuits? In the original, we also have the authentic. There is a clear link between these two concepts in the context of sound making and music. We can think real, true, and genuine, as opposed to a copy, fake, imitation, or the virtual. The DIY electronic musician seeks to establish some kind of authentic voice by working directly with materials through DIY practices. This authenticity can also lead to a form of legitimacy and validation in respect to resulting artwork, music. Looking at a specific example, Aphex Twin's fascination with old and vintage studio equipment is in many ways a show of authenticity rather than what might be thought of techno-nostalgia. Take the album Cyro. Accompanying the release is an extensive list printed on the album sleeve of equipment used on the recording that includes the full-tone tape echo, the Casio FZ10 keyboard, the Nagra tape recorder, and the Roland TR-808 drum machine. Within the context of music technology, Aphex Twin is making an implicit statement that this music is not made with virtual software or cheap reproduction hardware, or from sound sources and tools that are copies, but from genuine materials. Nathan Rosenberg, in his insightful book Inside the Black Box: Technology and Economics, argues that black box technology goes beyond the confines of its own physical boundaries and is closely entwined with politics and economics. And to break open and examine the contents of the black box can lead to insights relating to social economics. He ties technological progress to capitalism, debates Marx's view of technology on society and how, for example, specific technologies are linked to the economies of industrial, post-industrial societies. The black box is viewed by Rosenberg as being not only symbolic of technological progress, but directly responsible for productivity and wealth, transfer and speed of information that in turn determines government effectiveness. The microchip, therefore, can be seen as a symbolic value of power. Moreover, the microchip's spread into everyday life is often through stealth. Are we aware of its presence? How many microchips do we have in our homes? Aside from those found in a computer, what about, for example, those found in a fridge, kettle, TV, remote control, Wi-Fi router, heating control, hearing aid or pacemaker? Agriculture, health, education, art and music, for example, have not escaped its presence. Do we have any choice in our dependencies of such technologies? The hacker, as provocateur and political agitator, should be drawn to such black box technology as a moth is to light. There are contradictions in DIY electronic music between the stated aims and ethos of these community practices and the broader societal structures that support them. A significant percentage of the core electronic components used in DIY sound-making devices are not handmade or crafted, but developed by multinational corporate companies and are currently manufactured and mass-produced in Asia. An argument can also be made that inventions such as the integrated circuit, IC, and microchip are byproducts of imperialist capitalist societies whose development have been closely linked to the weapon industry. This is nothing new. It is worth noting that hobbyist electronics became popular after World War II due to the surplus of electronic components used in military appliances. Robert Moog made use of such resources in developing his early synthesizers. On an important ethical front, e-waste has become a global environmental issue. With the ever-growing popularity of modular synthesizers and booming array of available sound-making products, I critique such consumerism by putting forward the rhetorical question: how many oscillators does a musician need to create a piece of electronic music? Together, these issues pose a conundrum. Considering the way in which the electronics industry is structured, can there be such a thing as ethical electronic music or an ethical music technology? Let's return to the chip in the Radical Nails instrument. The specific chip is the PIC 12F1840. This is a programmable integrated circuit, PIC, manufactured by the company Microchip Technology. It's got a maximum internal clock of 32 MHz, 70 kilobytes program memory and 256 bytes of RAM. It cost about £1. Relatively speaking, in computer terms, it has its limitations, shall we say. But let's ask a few questions about this chip. Microchip Technology manufactures microprocessors and microcontrollers. Its sales for the fiscal year ending in 2019 were 5.3 billion. In 2016, it bought for 3.56 billion the rival company Atmel, the microprocessors that can be found in the Arduino. And what's the chip made of? As Harari and Hansen state, in general, computer equipment is a complicated assembly of more than 1,000 materials, many of which are highly toxic, such as chlorinated and brominated substances, toxic gases, toxic metals, biological active materials, acid, plastics, and plastic additives. Then there's the waste. Artist Danny Plurger has made an artwork, Back to Sender, H264, where he travels to an e-waste recycling site in Lagos, Nigeria, to highlight the extent of e-waste and the appalling conditions of workers at the site. Much of the e-waste at the site is shipped from around the world. Plurger has written extensively on consumer culture and the impact of e-waste on society from an artist's perspective. Across the globe, there has recently been the introduction of the right to repair laws that have challenged the obsolescence of technology and e-waste. In many countries, manufacturers of electronic appliances are now legally required to make spare parts available. When I first started making DIY electronic sound devices and instruments at the turn of the millennium, there was an abundance of readily available parts and components. Online suppliers were becoming the norm, often at the expense of small suppliers and shops, and you could get anything you wanted relatively cheaply within a few days. China was also opening up in terms of PCB manufacture. Many of the artwork circuit boards that I designed, such as the mute synths, were manufactured in China. But after the global financial crisis of 2008, prices began to rise. And now, post-pandemic, we are confronted by a global shortage of semiconductors. It's not so cheap anymore. The PIC 12F1840 was not made locally to me. It was made on the other side of the world and has been flown to a warehouse for distribution in the UK. Environmentally, it has quite a footprint. There are a couple of pressing issues. Can I come to terms with the idea that electronic components found in my sound-making devices are byproducts of an industry driven by commerce and weapon manufacture, or face the mountains of e-waste produced by consumerism? So now is it time to start to re-evaluate how and what I make? Be that bricklayer, make to amend and all that. A couple of years ago, I was given a box of random chips. They've just sat there in my office since. I've got no idea what any of them are or do, but I'm sure there's something in there for making sound. Perhaps this is my response to the chip shortage and the ever-increasing demands placed on our planet and the need for sustainability. I can make green noise.
John, thank you. You have been negotiating so many obstacles, trying to to respond to this crazy African down in South Africa. I honestly thank you from the bottom of my heart.
It was a great pleasure, Theo, to have the opportunity to talk about some of these things. One always feels it can be hard work doing a keynote, but what a lovely platform to really get a chance to think about some of the things I'm trying to express in this talk. And yeah, I feel particularly in this keynote, it just scratches the surface of quite a big area. Yes. And that's something that in my work, it's slowly emerged, something I've not really thought about so much prior to this, and perhaps I should have been thinking more about these things.
Right. Well, if we can act as a catalyst, you're booked for next year, please. So. I'm checking the chat line here, the chat room, some really wonderful ideas. Touch on so many points between our papers, respective papers from William's side, which is a very good point, because if I may, I'd like to fire off, if I may refer back to the presentation earlier today. Are you willing to divulge who is the sparrow and who is the crane?
Well, actually, yes, the keynote here is quite a lot of talking, but if you could refer back to the video that I did with Afro Rack, and there is some music there and some examples of the instrument that I was talking about. I think we tried to pick two of the common birds. So the sparrow is a very humble bird, really. And it's not particularly glamorous. And I think the crane is a symbol of Uganda, and it's quite commonly found there, I think, on the banks of Lake Victoria. So we picked two common birds. Okay. And they became like a metaphor to kind of describe ourselves, two contrasting, but yet some similarities between the two in the fact that they are common to our particular environment.
Wonderful. Amazing, absolutely amazing. Perhaps I should continue with my next question. I'm perplexed, confused, bemused, full of wonder when I think of lo-fi and hi-fi. Do you think lo-fi tech can produce hi-fi?
Yes, it's not just a technological aspect. I think I try to put that across in the talk. It's also a phenomenological aspect as well on how we perceive sound. Yes. Because like the Ursula Le Guin quote that I gave, a match actually is quite high tech. The ability to be able to light a fire. And when I think of some of the instruments, the examples that I gave, the microprocessor, one microprocessor is still incredibly sophisticated. Indeed. And because with some of the synthesizers, I mean, I could have talked just more about that. They don't have a DAC, actually, a digital to analog converter. So the actual signal on some of the output of these instruments is digital, quantized. If you zoomed in with an oscilloscope, you'd see the step. But of course, we hear kind of digital artifacts, and there is a characteristic, a quality to the sound. I mean, it is possible to add a very simple DAC, a resistor and a capacitor, a filter, basically a low-pass filter. And I think once you get into this level of detail, you don't really question whether it's lo-fi. It's just a different presentation of sound. We all go to great extent to get this kind of high quality digital analog converters in our studios, possibly. But what about it? An instrument that doesn't even have that. So I just don't really see this idea of low or high in the same way. It's all what it is. I think I try to express that.
Indeed, it is just phi.
Yes, exactly. Well, the word fidelity, of course, is we're caught up in this notion of reproduction as well of sound.
Yeah.
So a recording of a violin, and we're trying to faithfully present that violin as a recording. So it has a fidelity in that sense.
Indeed.
But,
indeed.
Yeah, but in the world of electronic sound, it is what it is.
Indeed. I may be mistaken, stand to be corrected, but I read an interview with Dr. Neve once. He was interviewed about his about the preamplifiers in the famous Neve console, and the interviewer, youngish chap, started to speak about the wonderful warmth and the saturation and the wonderful nature, you know, the wonderful qualities that, and Neve interrupted him and said, listen, we were trying our best to construct a preamplifier that did nothing to the signal except amplify it, you know. So your idea of we have to now have a rack of outboard Neve amps in order to add saturation, etc., etc., misses the point completely. So there for me is once again like a disconnect between what Phi eventually became and what its roots are, and that is it's a very interesting, very fascinating area to think about. So you've really, you know, stimulated a lot of, including Douglas Skinner. Douglas, if I may please ask that you pose your question.
Hi, Douglas.
Hi. This is I don't know what I'm reaching for here, but I had a friend in San Francisco where I lived, who was very proud of his music system setup. He had huge electrostatic speakers and a subwoofer as big as a kitchen table. And he had an amplifier that was about a foot long and about 9 inches wide and about 3 inches deep, and it had 3 dials. And I looked at this and I thought, I looked at all the other kit, and then I looked at this and I said, Barry, what's going on here? And he said, oh, now that's an interesting story. He said, that's a $700 amp. I said, what? $700 amp? But they cost, you know, the top of the range cost $5,000. So Barry said, well, it's an interesting story. This is a local company, a couple of guys who were sound engineers. And they sat down and worked out what the human ear could hear. And they stopped spending all the money on squeezing every last little distortion out of the signal, and they just worked on what's in the range. And that's why it's $700. Because they didn't bother about the rest. You can't hear it. So my question is this. What is outside the range? Is there any mechanical or computational or electronic way of bringing it into the range? And if we bring it into the range, does that ruin what's going on outside beyond our hearing?
John, you're muted. John, I think you're muted.
Okay, I'm there. There
we go.
Sorry about it. Sorry. What's going on, Douglas? Yes. Well, I had this conversation briefly last night with a sociologist in my local pub. And yeah, I confessed that I'd spent all of my life thinking about sound and focusing on sound and listening to sound. But I think, as I tried to put across in the talk, you know, the music remains a cultural phenomenon. Yeah, it is our ears hear sound, but actually what we make of it is something else. And that's very much, and I said to the sociologist that actually I should have spent more time thinking about the more cultural aspects of the sound I was making and less about 4-part harmony or listening to sound in the recording studio. So what's going on, you know, it's other stuff. It's not the sound itself. And it's a bit of a confession to say, yeah, I've spent too much time thinking about the sound.
Well, we are happy that you have. So that is excellent news, actually. If I may interrupt, what I found very helpful for myself, has been to try to train myself to not listen to the sound, but listen to the room, listen to the environment, and then listen to the sound itself, to develop a bit of an understanding of how a room or a piece of equipment changes a sound, and then to focus on the sound. For me, that has been really helpful.
Could I add there, one of the strategies I've adopted for performance is not to use a PA. This may sound odd,
wonderful.
but I bring my own little speaker system.
Right.
Some of the speakers are from old cars, and play my instruments through this DIY sound system. Of course, then you can prepare the speakers, you can put things on the speakers, you can spin the speakers, you can explore the space, you can move around the space. And ultimately, all electronic sound ends acoustically, doesn't it? Because it propagates from a loudspeaker into the space. So it's really helped. Yeah, and that's the most interesting aspect, actually, of the technology or the electronic sound and how we're confronted by it in the acoustic world. And certainly I feel that's another point of discussion, you know, how we diffuse or disseminate the sound and how we choose to do that. Again, at the university where I work, De Montfort University, and many other institutions have a kind of standard approach to sound diffusion. The Genelec loudspeaker, for example, it has become a very popular choice for many institutions. And they're wonderful speakers, but it does kind of give a uniformity, a certain standardization of the type of electronic sound that we're hearing. So again, not only do I think it's important to think about bespoke technology or technology that I have a close relationship with, but also how then that sound is propagated. I mean, even recording sound, I find incredibly problematic. And in fact, if you look at my output, there's a decade at least completely missing in terms of recorded music. And primarily this is due to the idea of presenting music in a space, in a context. And certainly with some of the students I work with, we would often, I mean, I've mentioned Alvin Lucier, who unfortunately died a couple of days ago, but some of his pieces, like opera with objects, where you tap an object with a pencil and then you can explore the space. Such a wonderful composer to help us think about space and the relationship between electronic sound and space as well. So to come back to your point, Theo, yes, not only do we think about the cultural context, but also the physical space in which we hear sound is so crucial, so crucial. And again, that's why I find recorded music deeply problematic.
Douglas, have I managed to confuse you?
It sounds almost as if you want to pull the ladder out from underneath.
Yeah, right. That's what composers do. Okay, so I'm hogging the airwaves here. Chat line.
William, Yes, William's talk was particularly, I think, had a lot of similarity, fascinating subject matter. And I will certainly go back over that and listen again to your talk, William. Thanks for that.
Well, then, John Richards, I don't have words. I can just say, thank you really from the bottom of my heart for everything you've done. And it's my sincerest wish that we can plot the future together and invite you down here physically. Get some rest and be well.
Thank you very much.